I think the more of them you do, like, the better you get at them. I think it's just recognition, right? So with this one, what do you want to do? You want to do the easiest thing you can, right? So you want to look at something and go, okay, well, if there was a C term here, that would be unfortunate because then I'd have to multiply. It'd be a complex trinomial. You don't want to do that, right? Complex trinomials are like a last-ditch resort. You don't want to do them, right? Because you got to do the table or decomposition, and then the other thing with the like the complex ones, a lot of the roots come out to be like half values or thirds, right? Which we'll see. You know, the roots don't come out nice with those ones, right? So with this one, do I have a y-intercept? I think the y-intercept is going to be at 0. Because it's what happens if I plug in x equals 0, right?
So right off the bat, should we just like plug in x equals 0?
Now I would check and see where the y-intercept is. I would just get in the habit of doing that. That's good practice. So if you do decide to take the 3u, right, after you've taken this, because my sister did that. She took the 3m and then took the 3u because that was a good prep for her, right? You're going to start doing, I don't think you guys would have gotten to stuff like this yet, but they're called rational functions. And what you have to do is like plug in values of x around something and see what the graph is doing, right? So a lot, like, you just want to use the points that you can get right off the bat, right? So like one of the ones you can get is if there's a y-intercept. So you always just plug in x equals 0 to see if there's a y-intercept right off the bat. Because if you can get 2 or 3 free points, then there's less work to do later, right? So I'm just in the habit of doing that, right? So you just always, like, anytime you have a function like that, just plug in x equals 0, see what you get, right? What spits out. So if I do that here, I'm going to get 5 times 0 squared, like plus 15, 0, right? They're both going to cancel. You're going to get 0. So then I know it's going to cross the origin somewhere. I don't know how the graph looks yet, but I know it has to go through that point, right? Any questions? Okay, so the next thing is like, okay, this is like pretty close to standard form. There's just no C value, right? Which is why if there's no C value, it came out to be 0, right, as the y-intercept. Because there was no C value, right? So if there's no C value, though, you still have to switch it to factored form. Like, you need 2 pieces. So this one you just look at and go, okay, well, I can go like this. I see that there's a 5 common in both these pieces, right? I'm going to write that out front. Then I'm like, okay, well, there's also an x in both those pieces, so I can also write that out front. And what's left? After you take that out, you divide both of them by 5x, imaginarily, right? You get x plus 3. So this isn't much different than the question we just finished doing, really, except for this side. This piece here is a little bit more tricky. You're like, what's the x value there? But the other side is what it is, right? I know one of the roots is going to be at x equals -3. You can't, the behavior doesn't change just because the equation looks different, right? If you have something inside the brackets, it's still like, it's the value that sets the bracket equal to 0. So there's one of the roots, right? So that's x equals -3. I'll do that in a different color. See it. All right. That's one of your roots, right? Then your other question is like, okay, well, that's one of the values. If I plug in x equals -3, I get 0 on this side, which is what I want. I want a y value of 0 to be the x-intercept, right? So then your other question is like, okay, what's the other value of x I can plug in there to give me 0 equals 0, right? Well, if I plug in x equals 0 here, 5 times 0 multiplied by 0 plus 3 is going to be 0, right? 0 multiplied by 3, which is equal to 0. So your other x-intercept is x equals 0. So it turns out the y-intercept from the initial beginning was actually the other root for this particular question.
Can it be 0 though? Or 3?
There is negative 3 right here.
But
The second one's 0.
oh yeah, because 5x.
So you could treat this like a separate, but you can put brackets around that if you want, right? It's saying the same thing. Now you're like, okay, what value do I have to put into that second value of x to make the whole thing equal 0? You can put in 0, right? That's almost an easy one. It's not easy unless it gets explained like that, but because you're like, oh, there's no plus minus, what's the value? But it's just 0, right? So those are your two roots, right? Now you can go through the process of figuring out where the axis of symmetry is, right? Which, you know the difference in the roots is 3, so it must be at 1.5, because 1.5 is the middle of 3, right? So it's at negative 1.5. Nope, that's at 1. Okay. We'll find negative 1.5. Okay. Then you just find out what the y value is by plugging in x equals 1.5. You can choose to do that in either of the two equations. You could do it here, or you can do it with this one. Either or. Why don't we do it with the second one? Because it looks... are we expecting this to open up or down? That's also a good question we didn't answer at the beginning. Up or down? Up. So where should I expect my vertex to be? Good. So it should not be up here, right? I know I should not get a positive number, because if I do, then it's going to be opening down. Right? So I know my vertex has to be somewhere in the negative values. Right? So you just got to do the math on that. 5 times... What is happening? What did everybody get?
Negative 11.25.
I got 18. Got 18.75.
I got 30.
You got 18.75? Oh, okay. Here, let's do it again. Let's everybody do it. See, I don't know. We have 4 different answers. We gotta figure out what's going on.
Wait, it's 50.
It's 5.
It's gonna erase
I put it
everything.
into my calculator exactly. It's negative.
5
Oh, I
times.
didn't have negative. It's still negative 11.25.
I got 18.75.
Where's
Yeah,
the
me too.
Where's the
What am I
negative
doing
from?
wrong?
I got.
Plus.
Yeah, I put it in exactly like that.
Do you have brackets?
Yeah.
When you square the negative, does it stay negative?
I got negative 18.75.
Okay, that's what I've got.
You got it. Thank you.
What? You got the same thing?
It's actually the So negative 1.5 squared.
I got 11.25.
How do you wait?
I got 11.25.
How do we get 2.5 from negative 1.5 plus 3?
Is that not the answer?
No, because it would be 1.5. Because negative 1.5 plus 3.
Okay, maybe that's what I did. I counted on the thing. Maybe I made a mistake.
Sorry, my brain just.
Mine's not working today either. So I keep making little silly errors. Yeah, you're right.
Yeah.
Okay, so this should be 1.5. Is that what you had, Ashley? Okay, so it's 11 points off.
What?
Negative 7.5
That?
times
Yes.
1.5.
Okay, so we're like in here.
Wow. I'm a visionary. Wow. I believed in myself when no one else believed in me.
Yeah.
And here I am.
There's your graph. Okay. What's the vertex? Let's make sure we got the vertex.
1 point or negative 1.5
Good.
and negative 11.25.
0.25, right? Good. Good. Okay. All right, here you go. This might be. I don't know if this one's gonna be messy or not. We'll see. This might be interesting. Right? No common factors here.
Is this a tricky try?
No
It's a
common
tricky try.
factors, no squares.
So you got a man.
You got a man, but then you got to do the table afterward, right? In order to get into factor form. So I need. Sorry. Gotta do man. See, look at me go. It's got to multiply to 6. Add to 5.
Oh, right. You gotta do
Wait,
It's always the A value multiplied by the C value. Always. Regardless if there's up here. What's here? An imaginary 1. 1 times negative 12 is negative 12. Always, always A times C. That way you never have to worry about it being a. Just always know it's A times C. Whatever the number is there times the C value. Okay. What do we got? 1 and 6 seems like it works, but there's no combination of negatives to make 1 and 6 work. So we go to the next one. 2 times what? 3. 2 and 3. 2 and 3 worked. Right? Now I cannot just write this like this. Do not do this. Every time we do one of these complex trinomials, I'm going to say this. Do not do this. Can't do that. If you see a number here, you have to do your table or decomposition. How would we like to see it?
decomposition.
I knew you were going to say that. Okay. 5x gets decomposed. That's why it's called decomposition. Into 3x plus 2x. And then you can split the trinomial down the middle, basically, and factor what's similar in the first two and factor what's similar in the second two. Right. So I could go, okay, in the first two here, I see that I could take out a 3x, and I'm going to write x plus 1, because that's what's left afterward. And then the second one, I see 2x plus 2, so I can take a 2 out, the x plus 1. Then I see the 2x plus 1s on either side, and I go, okay, well I can take the x plus 1s out, and then I write what's left. That's your factored form for that trinomial. Are we not happy with decomposition? We want to see the table?
Yes.
Sure.
Okay.
Makes sense.
Okay.
How did so?
No, he gets
When you really quick with the decomposition method, everything makes sense to me. But when we get to the part where you're finding common things that you can take out,
Like on the third line? Or the second
third line, like the line where you've got the 3x bracket x plus 1.
Yeah.
You don't. It doesn't have to be like in GCF where you have. Like, you can just take out anything as long as there's something left behind.
This is basically that is the GCF, right?
Yeah, but like normally, don't you have to find something that is common? Whereas, is it? Am I just?
Well, there's a 3 and an X there, and a 3 and an X here, right?
Oh, I see. I did it in reverse order and put the 3 on the
Oh,
other side. That's why.
okay. I will.
Which is
That
dumb.
question came up yet. Like Noah asked that question yesterday, so let me just do that. Okay, I'll do the table in a sec.
That makes sense now. I see.
When I do decomposition, I look to put similar things with similar things. But that's not to say that you can't flip the order in the middle. So if I do this, plus 2x, that looks ugly to me, right?
Yeah.
Plus 3x plus 2. Like, I don't like that. But there's nothing wrong with it. Because if I still break it down the middle, what's common in the first two? X. And then I write what's left, 3x plus 2. What's common in the second one? A 1. So then, the only thing that changes is what piece is similar amongst the two. Then you can pull those out, right?
Okay.
I like pairing things that look similar together, right? And to be honest with you, I've kind of forgot, well, not that I wouldn't do this way, if you've never seen decomposition, I think it's the harder way to factor tricky trinomials relative to the table. Right? What's that?
And you're a tricky trustee because it's an inside joke every time you say tricky trinomial.
Okay. So the table, let's do the table. 3x squared in the top left, 2 in the bottom left, 3x, and 2x. So then just start reading. Vertically, there's an x vertically, and then a 1. And these are all positive, so you don't have anything to worry about with the signs, but we'll do that after. And then left to right, horizontally, I've got 3x here, and then I've got 2 here.
Wait, why do you subtract on this one?
Nope.
And how did you only end up with X?
For this one,
Yeah.
because there's no number, you can't do anything with the 3 and 2.
Oh.
You can only do something with the 2 x's, right? That
Is
is
that 3x beside 3x squared or
here?
no, on the other side? The one that's
Yeah, it's a
on
3x.
window one.
Sorry.
Okay.
I looked at that and went,
You just forget about the numbers.
the sign, yeah, for that one. If this was a 4, then you could take out a 2. Right? But it's not a 4, so we're stuck. Okay? So it's 3x plus 2 and x plus 1. That matches what we did with the decomposition. Okay, I'm going to erase the green section because I need the space to do this question. Now, we can also look at what should the y-intercept be? 2. Why is it 2? It's the C value written standard form. So I know it has to go through this point.
Okay.
Do you get it? No?
No.
Oh, okay. Okay.
I understand that it has to go through that point because there's the plus 2 and that's the y-intercept. I understand that.
Do you know how I get it?
You plug 0 into the start and whatever is left
Why am I choosing 0?
because it.
What's the x value right here?
X 0? Yeah, I understand that.
Okay.
No, my confusion was just because me and Haley did the question really wrong up to that point. I think it's fine.
Okay. So we have the y-intercept. Let's come up with the 2 x-intercepts now. Nice thing about parabolas is then you get 3 points on the graph. Right? First one's easy. It's always opposite of what's there. X equals -1. The second one, remember, this comes into the solving stuff, and this typically happens with the complex trinomials, where you get these kind of ugly things. But remember, this bracket has to equal 0. has to equal 0, right, in order to satisfy. So if I make this bracket equal to 0, same thing I did here, right? Let me write this one because it might be useful. This is what I did here, right? I said x plus 1 equals 0. And I solved for the value of x that made that work. So I just took the 1 and I moved it over, and x is equal to negative 1. So I'm going to do the same thing here. Right? 3x is equal to negative 2. X is equal to negative 2 over 3.
So then now you have to find out
Where the middle is. That's the hard part.
That's
That's what's not nice about complex
wouldn't you
trinomials.
just divide, like go negative 2 divided by 3 and then
What did you get for the 0 value? Or have we not?
0 value. Like the x-intercepts?
Yeah,
Those are them there.
I just put in for 0 when I got
Oh, that would be the y-intercept.
Oh.
Yeah. Right, so I can go plot that one. And negative 2/3. Oh, this is tight. Let me zoom in. So I know one is at negative 1, and the other one's at negative 2/3. Well, this is not a great question. I probably wouldn't do this to you on the test.
0.6 out of that pair.
Oh my god.
So you just got to find the middle of those 2 points. Right? So how would I find the middle of those 2 points? Where you see the 2 points?
Okay, wait, no, sorry. Negative. How does it cross through the? Well, it's positive. How does it cross through?
I know the parabola is going to do something like this is just going to be a general. I don't know that it's going to how far down it's going to go. This is the problem, right? This is why we're trying to figure out where the vertex is, because I could have the graph do this, or it could do this, right? I don't know how far down it goes. It starts to really get stretchy the further you go down, but I know it has to be something like that, right? I just don't know where the vertex is yet. That's what we're doing next, right? I know it has to be somewhere in between those 2 roots, right? I just don't know where. Right? So what you have to do, this works with the average that I was telling you about yesterday, right? So if I go negative 1 plus negative 2 over 3 divided by 2, that'll tell me the middle of those 2 points.
0.8. No. Yes. It's 0.8. That's what I got.
That sounds about right. Right? Has to be in between 1 and 0.67 or whatever it is, right?
I inputted I found the middle.
Right? So if I type that in, 0.83. Not that it really matters. Pretty close here. Okay, so this is a horrible question. This is kind of my bad. I should have worked through this one. The idea is the same. Right? Yeah, Ian. Yeah. I had to zoom in to draw the axis symmetry in.
How come you did in man multiply? How come you did the A value instead of the N value? For the M. You did 6, which is the A value. You did it 3 times.
It's 3 times 2.
Oh yeah, I guess.
It's complex, right?
And wouldn't it be 0? You'd end up with like negative 1 and negative 2/3, but negative 2/3 would then equal
0.6667.
yeah.
So you just add those 2 together and divide by 2.
So
That's the red line.
0.667. Why is it on the negative side?
Doesn't matter.
Maybe it.
They're both negative, right?
Oh, okay. No, they are both negative. That's just my brain not. Okay, cool.
Okay.
Choice.
So then the last step to this to figure this out is you go, okay, well, how far down did it go? Well, let's plug in, we have to plug in y equals 0.83 plus 1. Right? And then 3 times 0.83 plus 1. Plus 2, sorry. Right? You'll get an answer, whatever that is. 1.83 multiplied by 3.64 or something. I don't know. Whatever it is. Did anybody get an answer? Oh, it also has to be negative. Sorry. Sorry.
The board said that they can precautions based off of when people come back from March break. If you feel slightly sick, you have to stay home in like a 2-week period, and they're gonna take it by day.
Ooh, I feel slightly sick after being 18 in the whole March break. Well,
Oh
it's
no, I've
only
been in
if
my
you've gone
bedroom.
Is it bad that I really want my work to cancel?
Did anybody get an answer? Do we know where that's sitting?
It'd be around like your negative 0.83.
So it's really, really small.
Yeah.
So it's like right here.
Yeah.
So then your parabola looks something like this. This is a horrible question.
It's a cute little tiny.
Can't even see the points. Okay, so here's the new piece of information. Okay, so hopefully this resonates with you because we just finished doing 3 questions and then all of factoring. And why do we do factoring? And like this is the last step, right? It's your last line of defense, and just conveniently it always works. Okay. So so what happens if the equation written in standard form isn't factorable? How are you going to produce a graph? Right? How are you going to answer questions like how far did something go, how long did it take, stuff like that? Okay? I'll play you the song after. You'll never forget it again. Negative,
Oh, no.
negative b plus or minus the square root of b squared minus 4ac all over 2a.
I forgot about this.
Bro, I need to do this
Oh.
or do this.
It's not that I can't remember it. It's just that
What?
it's so easy to screw up typing into a calculator, and you have the wrong answer.
Yep.
Oh my goodness, I forgot about this.
Okay. So actually there is one more thing that you do not want to do above complex trinomials. It's this stupid thing. This is a last resort, right? This is like, if I can't do anything, then you got to use this. Right? You would prefer to do a complex trinomial factoring than type it into this thing. Okay?
Will you always get a right answer if you use
Yes.
quadratic equation?
Yes. It works no matter what. Okay? So, let's look at this one. Let's try, we'll go through our checklist. No greatest common factor. Can't do perfect square trinomial, no difference of squares. Let's go, okay, so we're going to do a complex trinomial now. Aiden, do you know what's going on?
Yeah, we're doing periodic.
Are we? I don't know. I'm going to try and factor this first. Oh, that's not factoring. What are the 2 numbers?
Wait, so that's like quadratic. No, never mind. I thought that's like quadratic. This is a hard
Do you want us to do this on the quadratic formula?
Do I want you? I don't want you to ever do quadratic equation unless you have to. Do you have to use it?
No,
What do you mean?
you don't have to use this one, you can.
What? Do you have two numbers at work?
Oh, well, I mean, I'm doing the quadratic formula right now, I kinda just did it.
Well,
Can you tell me two numbers that multiply to 2 and add to 8?
It's not.
Probably very, very, very small.
But then if they're very small decimal numbers, are they ever going to add to 8?
No idea.
It hurts your head. If it hurts your head, chances are you got to use quadratic equation,
Okay.
right? There's no two numbers to make that work. It's not happening. So now you got to go, okay, well, I got to use this stupid thing, right? So negative b plus or minus the square root of b squared minus 4ac all over 2a. Am I missing a negative? Just before we get too carried away.
I don't think so.
I don't think so either, but let me just check.
Okay. Wow. This is what I'm glad I have. Hector, you need to get a calculator.
no, it's out of principle. I can do it in my head.
You probably get a calculator and then lose it.
Okay, we're good. Okay. Let's just visually, for those of us who have never seen this before. 2 is the A value, goes with the A's. B goes with all the B's. And then the C value goes with the C value. You just plug the numbers in. Now the catch is, be careful with this little thing here. This is how we get this is the last little step, the plus minus thing. So, just plug everything in. I got negative 8 plus or minus the square root of 8 squared minus 4 times 2 times 1. Divided by, well, it's all over, is it all over 2a? It is all over 2a.
Yeah.
Sorry. All of that is over 2a. Sorry, everybody. The whole thing.
I already have the answer for it if you want me to. So,
Well, you can confirm if I'm right or wrong. Or I'll confirm if you're right or wrong.
that'll probably be
Oh,
What's the matter?
maybe I'm just bad at math, but it's giving me a prime number when you divide by
What's the problem?
a number that doesn't, it can't be.
Are we gonna be using
Like 13 would be an example of a prime number.
like
It's
rad
not
cans?
multiply.
No.
What did you get?
Yeah.
So then you have
2 plus root 48? Oh,
no, like 2
You're not gonna get
I might have to do that in the exponentials, but
Oh.
I would type it in.
It's gonna give us a decimal.
I hate
That's
when,
fine.
like,
That's
the
fine for the
radical
roots.
calculator,
So are we using decimals
you,
now,
like,
right?
accidentally hit
Yeah,
the
right now.
Okay.
Because a radican means nothing to you when you go to plot the root, right?
That could just automatically
Yeah.
put
You'd have to type it in anyway. Yeah. We might have to do that in
Is there like a way to do that?
exponentials.
Alright. Because that's what we're doing in my other.
Yeah, all the radical work we'll probably do in exponentials.
Yeah, it's basically small radicals.
Okay, good. So you should be good at that then. Yes.
Is there a way on here? I don't know if you know the calculator. Can you just put the quadratic formula
Yes,
on here
you
to
can.
fill in?
I'm not going to tell you how to do it though.
Hey, Mo.
I'm gonna tell you how to prevent making you waste brain cells.
There you go. 64 minus 8, all divided by 4, right? Negative 8 plus or minus,
the square root of 56, which equals 7.48.
That's where 56.
I just put Wait, why does it down?
Four minus
So we erased the thing on the board.
minus 4.
sorry.
It looks like a unicorn.
It was a trig question from yesterday.
Wait.
Is this for plus or minus?
Both.
Both.
You gotta do both of them.
I found both.
Oh, okay. I haven't done it yet.
Oh,
I'm still
okay.
I'm just still going through the tedious
I never got there last year. I just kind of got it.
stuff. So, okay, what's the root of 56?
7.48.
Where'd the 2 and
I
the 1
rounded.
come from?
You what?
Where'd the 2 and the 1 come from? Way up at the.
Right here. Follow the colors. Red goes with red. Blue goes with
Yeah,
blue.
no, I understand like the where they go, like how where they're supposed to go. I just mean like the 2 and the 1 specifically is the numbers. Oh,
I multiplied.
A.
4 times 2. 8
Yeah.
times 1.
Four times 2 is 8. -8.
Times 1.
Oh, I see. That's where I did it.
Yeah, Aiden.
Once you get the 2 answers, what do you do then?
You plot them. Those are your roots.
Oh, these are x values?
Yep, they're the x-intercepts.
Oh, okay.
You plot those on the graph.
Wait, what numbers are?
The final answers. So you'll get
plus and minus. Those are the 2 x-intercepts. So that's for 56.
no plus. No, hold on. Let's finish this. -8 plus 7.48. What's that? I'll do the plus one first. What's that equal to? Somebody give me a number. Okay. And then I get -8 minus 7.48 divided by 4. What's that?
Negative 15.48.
15.5. Okay. Those are your roots. So you have one root at x equals -0.52, and the other one's at
Did you want the divided version? Like the.
See, this is
That's,
oh the divided version. Yeah, I wanted the
oh,
answers.
Yeah. That's -0, -0.13.
Sorry.
Sorry.
It's okay. Which is equal to what?
-0.13 for the first one, and then -3.75.
It's only wrong. That's fine. I got -4 and 11. So there we go.
Okay, here are your roots. You go plot them on the graph.
okay.
Right? So I'd go out to my graph, I'd plot the 2 roots, and I'd go through the exact same process to find the axis symmetry, plug that number in, get that vertex, and then you can connect all the dots. Okay? Is that good?